How aircraft carriers work. At its most basic level, an aircraft carrier is simply a ship outfitted with a flight deck, a runway area for launching and landing airplanes. This concept dates back almost as far as airplanes themselves. Within 10 years of the Wright brothers' historic 1903 flight, the United States, the United Kingdom and Germany were launching test flights from platforms attached to cruisers. The experiments proved largely successful, and the various naval forces started adapting existing warships for this purpose. The new carriers allowed military forces to transport short-range aircraft all over the world. The USS Ronald Reagan, one of the U.S. Navy's nuclear-powered super aircraft carriers, didn't play a huge role in World War I, but they were central to the air combat of World War II. For example, the Japanese launched the 1941 attack on Pearl Harbor from aircraft carriers. Today, super aircraft carriers are a crucial part of almost all major U.S. military operations. While the ship itself isn't especially useful as a weapon, the air power it transports can make the difference between victory and defeat. One of the major obstacles of using air power in war is getting the planes to their destination. To maintain an air base in a foreign region, the United States, or any other nation, has to make special arrangements with a host country, and then has to abide by that country's rules, which may change over time. Needless to say, this can be extremely difficult in some parts of the world. Under international freedom of navigation laws, aircraft carriers and other warships are recognized as sovereign territories in almost all of the ocean. As long as a ship doesn't get too close to any nation's coast, the crew can carry on just like they're back home. So, while the U.S. military would have to make special arrangements with a foreign nation to set up a land military base, it can freely move a carrier battle group, an assembly of an aircraft carrier and 6 to 8 other warships, all over the globe, just as if it were a little piece of the United States. Bombers, fighters and other aircraft can fly a variety of missions into enemy territory, and then return to the relatively safe home base of the carrier group. In most cases, the Navy can continually replenish, resupply, the carrier group, allowing it to maintain its position indefinitely. Carriers can move in excess of 35 knots, 40 miles per hour, 64 knots per hour, which gives them the ability to get anywhere in the ocean in a few weeks. The United States currently has 6 carrier groups stationed around the world, ready to move into action at a moment's notice. Basic structure. With about 1 billion individual pieces, the U.S. Nimitz-class supercarriers are among the most complex machines on Earth. But on a conceptual level, they're pretty simple. They're designed to do 4 basic jobs: transport a variety of aircraft overseas, launch and land airplanes, serve as a mobile command center for military operations, house all the people who do these things. To accomplish these tasks, a carrier needs to combine elements of a ship, an air force base, and a small city. Among other things, it needs a flight deck, a flat surface on the top of the ship where aircraft can take off and land, a hangar deck, an area below deck to stow aircraft when not in use, an island, a building on top of the flight deck where officers can direct flight and ship operations, room for the crew to live and work, a power plant and propulsion system to move the boat from point to point and to generate electricity for the entire ship, various other systems to provide food and fresh water and to handle things that any city has to deal with, like sewage, trash and mail, as well as carrier-based radio and television stations and newspapers, the hull, the main body of the ship, which floats in water. The hull of the ship is made up of extremely strong steel plates, measuring several inches thick. This heavy body is highly effective protection against fire and battle damage. The ship's structural support largely comes from 3 horizontal structures extending across the entire hull: the keel, the iron backbone on the bottom of the ship, the flight deck and the hangar deck. The hull portion below the water line is rounded and relatively narrow, while the section above water flares out to form the wide flight deck space. The lower section of the ship has a double bottom, which is pretty much what it sounds like. There are 2 layers of steel plating. The bottom plating of the ship and another layer above it, separated by a gap. The double bottom provides extra protection from torpedoes or accidents at sea. If the enemy hits the bottom of the ship, smashing a hole in the outer steel layer, the second layer will prevent a massive leak. Construction. Since the 1950s, almost all U.S. supercarriers have been constructed at Northrop Grumman Newport News in Newport News, Virginia. To make the construction process more efficient, most of each supercarrier is assembled in separate modular pieces called superlifts. Each superlift may contain many compartments, rooms, spanning multiple decks, and they can weigh anywhere from 80 to 900 tons, 70 to 800 metric tons. A supercarrier is made up of almost 200 separate superlifts. Before placing a superlift module into the ship, the construction crew assembles its steel body and hooks up almost all wiring and plumbing. Then they use a giant bridge crane to lift the module and lower it precisely into its proper position inside the ship. Then they weld it to the surrounding modules. Near the end of construction, the crew joins the last module, the 575-ton island, to the flight deck. Just like the family motor boat, an aircraft carrier propels itself through the water by spinning propellers. Of course, at about 21 feet, 6.4 meters, across, a carrier's 4 bronze screw propellers are in a very different league than a recreational boat's. They also have a lot more power behind them. Each propeller is mounted to a long shaft, which is connected to a steam turbine powered by a nuclear reactor. The carrier's 2 nuclear reactors, housed in a heavily armored, heavily restricted area in the middle of the ship, generate loads of high-pressure steam to rotate fan blades inside the turbine. The fans turn the turbine shaft, which rotates the screw propellers to push the ship forward, while massive rudders steer the ship. The propulsion system boasts something in excess of 280,000 horsepower. The Navy doesn't release exact numbers. The 4 onboard turbines also generate electricity to power the ship's various electric and electronic systems. This includes an onboard desalination plant that can turn 400,000 gallons, 1,500,000 liters, of salt water into drinkable freshwater every day. That's enough for 2,000 homes. Unlike the old oil boiler carriers, modern nuclear carriers don't have to refuel regularly. In fact, they can go 15 to 20 years without refueling. The trade-offs are a more expensive power plant, a longer, more complicated refueling process. It takes several years, and the added risk of a nuclear disaster at sea. To minimize the risk of such a catastrophe, the reactors inside a supercarrier are heavily shielded and closely monitored. Taking off. An aircraft carrier flight deck is one of the most exhilarating and dangerous work environments in the world, not to mention one of the loudest. The deck may look like an ordinary land runway, but it works very differently, due to its smaller size. When the crew is in full swing, planes are landing and taking off at a furious rate in a limited space. One careless moment, and a fighter jet engine could suck somebody in or blast somebody off the edge of the deck into the ocean. But as dangerous as the flight deck is for the deck crew, they have it pretty easy compared to the pilots. The flight deck isn't nearly long enough for most military planes to make ordinary landings or takeoffs, so they have to head out and come in with some extraordinary machine assistance. To make takeoff a little easier, carriers can get additional airflow over the flight deck by speeding through the ocean, into the wind, in the direction of takeoff. This air moving over the wings lowers the plane's minimum takeoff speed. Getting air moving over the deck is important, but the primary takeoff assistance comes from the carrier's 4 catapults, which get the planes up to high speeds in a very short distance. Each catapult consists of 2 pistons that sit inside 2 parallel cylinders, each about as long as a football field, positioned under the deck. The pistons each have a metal lug on their tip, which protrudes through a narrow gap along the top of each cylinder. The two lugs extend through rubber flanges, which seal the cylinders, and through a gap in the flight deck, where they attach to a small shuttle. To prepare for a takeoff, the flight deck crew moves the plane into position at the rear of the catapult, and attaches the tow bar on the plane's nose gear, front wheels, to a slot in the shuttle. The crew positions another bar, the holdback, between the back of the wheel and the shuttle. While all of this is going on, the flight crew raises the jet blast deflector, JBD, behind the plane. After the plane, in this case. When the JBD, tow bar and holdback are all in position, and all the final checks have been made, the catapult officer, also known as the shooter, gets the catapults ready from the catapult control pod, a small, encased control station with a transparent dome that protrudes above the flight deck. When the plane is ready to go, the catapult officer opens valves to fill the catapult cylinders with high-pressure steam from the ship's reactors. This steam provides the necessary force to propel the pistons at high speed, slinging the plane forward to generate the necessary lift for takeoff. Initially, the pistons are locked into place, so the cylinders simply build up pressure. The catapult officer carefully monitors the pressure level so it's just right for the particular plane and deck conditions. If the pressure is too low, the plane won't get moving fast enough to take off, and the catapult will throw it into the ocean. If there's too much pressure, the sudden jerk could break the nose gear right off. When the cylinders are charged to the appropriate pressure level, the pilot blasts the plane's engines. The holdback keeps the plane on the shuttle while the engines generate considerable thrust. The catapult officer releases the pistons. The force causes the holdbacks to release, and the steam pressure slams the shuttle and plane forward. At the end of the catapult, the tow bar pops out of the shuttle, releasing the plane. This totally steam-driven system can rocket a 45,000-pound plane from 0 to 165 miles per hour in 2 seconds. A 20,000 kilograms plane from 0 to 266 knots per hour. If everything goes well, the speeding plane has generated enough lift to take off. If not, the pilot, or pilots, activate their ejector seats to escape, before the plane goes hurtling into the ocean ahead of the ship. This hardly ever happens, but the risk is always there. Taking off is extremely difficult, but the real trick is coming back in. In the next section, we'll take a look at the standard carrier landing, or recovery, procedure. Landing. Landing on a flight deck is one of the most difficult things a Navy pilot will ever do. The flight deck only has about 500 feet, 150 meters, of runway space for landing planes, which isn't nearly enough for the heavy, high-speed jets on U.S. carriers. To land on the flight deck, each plane needs a tailhook, which is exactly what it sounds like. An extended hook attached to the plane's tail. The pilot's goal is to snag the tailhook on one of 4 arresting wires, sturdy cables woven from high-tensile steel wire. The arresting wires are stretched across the deck and are attached on both ends to hydraulic cylinders below deck. If the tailhook snags an arresting wire, it pulls the wire out, and the hydraulic cylinder system absorbs the energy to bring the plane to a stop. The arresting wire system can stop a 54,000-pound aircraft traveling 150 miles per hour in only 2 seconds, in a 315-foot landing area. A 24,500 kilograms aircraft traveling at 241 knots per hour in a 96-meter landing area. There are 4 parallel arresting wires, spaced about 50 feet, 15 meters, apart, to expand the target area for the pilot. Pilots are aiming for the 3rd wire, as it's the safest and most effective target. They never shoot for the 1st wire because it's dangerously close to the edge of deck. If they come in too low on the 1st wire, they could easily crash into the stern of the ship. It's acceptable to snag the second or fourth wire, but for a pilot to move up through the ranks, he or she has to be able to catch the third wire consistently. To pull off this incredible trick, the pilot needs to approach the deck at exactly the right angle. The landing procedure starts when the various returning planes stack up in a huge oval flying pattern near the carrier. The carrier air traffic control center below deck decides the landing order of the waiting planes based on their various fuel levels. A plane that's about to run out of fuel comes down before one that can keep flying for a while. When it's time for a plane to land, the pilot breaks free of this landing pattern and heads toward the stern of the ship. Landing signals officers, LSOs, help guide the plane in, through radio communication as well as a collection of lights on the deck. If the plane is coming in okay, the LSOs will illuminate green lights to tell the pilot everything is okay. If the plane is off course, the LSOs can illuminate other lights to correct him or her or wave him off, send him around for another attempt. In addition to the LSOs, pilots look to the Fresnel lens optical landing system, commonly referred to as the lens, for landing guidance. The lens consists of a series of lights and Fresnel lenses mounted to a gyroscopically stabilized platform. The lenses focus the light into narrow beams that are directed into the sky at various angles. The pilot will see different lights depending on the plane's angle of approach. If the plane is right on target, the pilot will see an amber light, dubbed the meatball, in line with a row of green lights. If the amber light appears above the green lights, the plane is coming in too high. If the amber light appears below the green lights, the plane is coming in too low. If the plane is coming in way too low, the pilot will see red lights. As soon as the plane hits the deck, the pilot will push the engines to full power, instead of slowing down, to bring the plane to a stop. This may seem counterintuitive, but if the tailhook doesn't catch any of the arresting wires, the plane needs to be moving fast enough to take off again and come around for another pass. The landing runway is tilted at a 14-degree angle to the rest of the ship, so bolters like this can take off from the side of the ship instead of plowing into the planes on the other end of the deck. As soon as an aircraft lands, it's pulled out of the landing strip and chained down on the side of the flight deck. Inactive aircraft are always tightly secured to keep them from sliding around as the deck rocks back and forth. The flight deck crew has to be prepared for a wide range of unexpected events, including raging aircraft fires. During takeoff or recovery operations, they have plenty of safety equipment at the ready. Among other things, the flight deck has a small fire truck, and nozzles leading to water tanks and aqueous film-forming foam, an advanced fire extinguishing material. There are also nozzles for jet fuel and a number of other useful liquids. The plane had to make an unconventional landing due to a problem with its landing gear. Flight deck personnel also face the risk of a jet engine blowing them overboard. Safety nets around the side of the flight deck offer some protection, but for extra safety, personnel are also equipped with float coats, self-inflating jackets with flashing distress lights, activated by contact with water. Flight deck personnel also wear heavy-duty helmets, called cranials, which protect their head and their hearing. The island. An aircraft carrier's island is the command center for flight deck operations, as well as the ship as a whole. The island is about 150 feet, 46 meters, tall, but it's only 20 feet, 6 meters, wide at the base, so it won't take up too much space on the flight deck. The top of the island, well above the height of any aircraft on the flight deck, is spread out to provide more room. The top of the island is outfitted with an array of radar and communications antennas, which keep tabs on surrounding ships and aircraft, intercept and jam enemy radar signals, target enemy aircraft and missiles, and pick up satellite phone and TV signals, among other things. Below that is the primary flight control, or pre-fly. In the pre-fly, The air officer and air officer assistant, known as the air boss and the mini boss, direct all aircraft activity on the flight deck and within a 5-mile, 8 kilometers, radius. The air boss and mini boss, both experienced aviators, have an array of computers and communications equipment to keep tabs on everything. But they get a lot of information just by looking out their windows, 6 stories above the flight deck. When an approaching plane gets within 3/4 of a mile, 1.2 kilometers, the landing signals officers take over control to direct the landing procedure. At the same level as the pre-fly, crew and visitors can walk out onto Vulture's Row, a balcony platform with a great view of the entire flight deck. The next level down is the bridge, the ship's command center. The commanding officer, the captain, usually controls this ship from a stately leather chair surrounded by computer screens. The commanding officer directs the helmsman, who actually steers the carrier, the lee helmsman, who directs the engine room to control the speed of the ship, the quartermaster of the watch, who keeps track of navigation information, and a number of lookouts and support personnel. When the commanding officer is not on the bridge, he puts an officer of the deck in charge of operations. Interestingly enough, many carrier commanding officers are former Navy airplane pilots, so they have a personal understanding of flight deck operations. As long as they're in command of a carrier, however, they're prohibited from climbing into the cockpit to fly a plane themselves. Just like the pre-fly, the bridge is outfitted with an array of high-end monitors, including GPS receivers and many radar screens. But the commanding officer and his team still rely heavily on their own eyes to keep tabs on activity around the ship. The level below the bridge is the flag bridge, the command center for the admiral in charge of the entire carrier group. Below that, there are various operational centers, including the flight deck control and launch operations room. In this tight, windowless space, the aircraft handling officer, also called the handler or mangler, and his or her crew keep track of all the aircraft on the flight deck and in the hangar. The handler's primary tracking tool is the Ouija board, a 2-level transparent plastic table with etched outlines of the flight deck and hangar deck. Each aircraft is represented by a scale aircraft cut out on the table. When a real plane moves from point to point, the handler moves the model plane accordingly. When the plane is out of service, because it needs repair work, the handler turns it over. There are a number of additional control centers below deck, including the Carrier Air Traffic Control Center, CATC, which takes up several rooms on the galley deck, immediately below the flight deck. Like a land-based air traffic control center, the CATC is filled with all sorts of radio and radar equipment, which the controllers use to keep track of aircraft in the area, in this case, mainly the aircraft outside the air boss's supervision. The CATC is next to the Combat Direction Center, CDC, the ship's Battle Command Center. The CDC's primary responsibility is to process incoming information on enemy threats, in order to keep the commanding officer fully informed. The hangar. The flight deck crew can keep a small number of aircraft up top, but there's not nearly enough room for the 80 to 100 aircraft stationed on a typical carrier. When they're not in use, most of the aircraft are secured in the hangar bay, the carrier's garage. The hangar bay is located 2 decks below the flight deck, just below the galley deck. The bay itself is 110 feet, 34 meters, wide, 25 feet, 8 meters, high, and 685 feet, 209 meters, long, more than 2/3 the length of the entire ship. It can hold more than 60 aircraft, as well as spare jet engines, fuel tanks and other heavy equipment, in 4 zones divided by sliding doors, a safety precaution to stop a fire from spreading. The hangar is 3 decks high, and it's flanked by various single-deck compartments on both sides. There are also 4 giant elevators surrounding the hangar, which move the aircraft from the hangar to the flight deck. The high-speed, aluminum hydraulic elevators are big enough and powerful enough to lift two 74,000-pound, 34,000 kilograms, fighter jets. After the hangar bay, in the stern of the ship, you'll find the Aircraft Intermediate Maintenance Division, AIMD, shops. The men and women in these shops are constantly repairing and testing aircraft equipment to keep the flight squadron at full force. At the very end of the ship, the AIM shops lead to an open-air engine testing area on the ship's fantail. This is the only place on the ship where the maintenance crews can safely blast aircraft jet engines to make sure they're working properly. Life on board. The modern supercarrier is widely referred to as a city at sea. With between 5,000 and 6,000 people working, relaxing, eating and sleeping on board for months at a time, this is certainly accurate. But it's not at all like any city you would find on dry land. For starters, most residents have little opportunity to see the outside world. The flight deck, hangar and fantail all have wonderful views of the sea and sky. But they are so hectic and dangerous that only a handful of people are allowed access during normal operations. The top levels of the island are safe enough, but sensitive operations and limited space means you can't have a lot of people coming and going. A sailor who works below deck might go weeks and weeks without ever seeing daylight. Throughout the ship, conditions are much more cramped than in a normal city. To get from place to place, personnel have to scale nearly vertical steps and squeeze past each other in narrow corridors. The berthing compartments, sleeping quarters, are extremely tight. Enlisted personnel share a compartment with about 60 other people, all sleeping in single bunks, generally called racks, crammed together in stacks of 3. Each person gets a small stowage bin and upright locker for clothes and personal belongings, and everybody in the compartment shares a bathroom, and a small common area with a television hooked up to one of the carrier's satellite dishes. Officers enjoy more space and finer furnishings, but their space is limited, too. Everybody on board has to get used to tight quarters. Jobs are highly varied, just like in a normal city. Approximately 2,500 men and women form the air wing, the people who actually fly and maintain the aircraft. Another 3,000 or so people make up the ship's company, which keeps all parts of the carrier running smoothly. This includes everything from washing dishes and preparing meals to handling weaponry and maintaining the nuclear reactors. The ship has everything its residents need to live, even if it's not as comfortably as they would like. There are multiple galleys, kitchens, and mess halls on board, which collectively serve as many as 18,000 meals a day. The ship also has a sizable laundry facility, dentist and doctor's offices, various stores, and a bank of telephones where personnel can talk to their families via satellite. Life on board an aircraft carrier is undeniably difficult and exhausting, but it can also be exhilarating, especially for the men and women up on the flight deck, flying and bringing in planes on a tiny patch of runway. Good or bad, it's like no other place on Earth. And this is all about how aircraft carriers work. Till next time.